Hello, everyone. Welcome back to SAT Math Question of the Day with Professor Emeritus Seth Chaiken at University of Albany and Seth's brother Joel. We're here to hopefully help you go through how to approach SAT math questions, maybe even all types of math questions. So here we have questions from we're doing Khan Academy practice, which is highly encouraged to do. The SAT allows you to do free practice on Khan. Essentially, they tell you what's on the test, and they give you questions to back that up. So there are 40 topics. This is called nonlinear equations. So let's start. Okay, please read the question and think about it, answer it, and come back, and we'll do it. Okay. So we have two functions that look like parabolas, up and down parabolas, are graphed in the xy plane. Which of the following must be true? The emphasis on the word must be true of the graphs of the vertices in the axis symmetry of the two functions. So we're focusing on the vertices and the axes of symmetry. The functions.
Also minimum values?
No, well, the vertex is the minimum value and the maximum value. I mean, inside the vertex is embedded the idea of the maximum and minimum values. Okay, the functions will have different vertices. Maybe, I don't know. Let's see. The functions will have different axes of symmetry. The function will have a minimum value.
Okay. After reading three of the questions, my approach would be to get out my eyeballs. And look at the equations.
Right. Okay.
Look at and see what is the same about them and what's different.
Right.
Both of them end with -4s.
Yep.
And both of them have a term 3 times quantity x minus 2 squared. But the third, however, is the 3 times x plus 2 quantity squared. Those two terms have opposite signs.
Right.
Okay. So what does that tell you?
It tells you one goes up and one goes down. That tells you one goes
Yes, up. One goes up and one goes down. So which one goes up and which one goes down?
This one goes up and this one goes down because it's got the negative sign.
All right. So you could answer between. So you could use that to decide between C and D.
Right. Exactly.
Now, does up up versus down?
Yeah, up has a minimum and down has a maximum. Right. So up has a minimum.
So the minimum.
Right.
And maximum.
Right.
So we got one. We could see C. We have to choose how many. Which of the following? So it's multiple answers, right?
Right.
So this one is yes, and this one is no. Okay. Now let's ask about different vertices versus different symmetries. Okay. Well, let's see. Vertex is where the square term, the vertex is where the thing that's squared vanishes.
Right.
Comes 0. And so this one has a vertex. This one has the vertex at x equals -2, and same with this. However, we have to rule out the possibility that, one of them looks like this, and one of them looks like that, with two different vertices. Well, that's not the case because both of them, when the square term vanishes, what's left is -4
Right.
is equal.
Right.
So, yes. Now, do they have different axes of symmetry? Well, again, looking at this visualization, finally visualizing it. Well, here's the picture. At x equals 2, right? We have the one that goes up like this. Through the vertex, let's draw the horizontal line where y equals -4. And the other one goes like this. All right, so what are the axes of symmetry? There are 2 axes of symmetry.
No, there's only one. The axis.
No, there are 2 axes of symmetry. There's a vertical axis. You flip them over there, and this one is the top one and the bottom one are horizontally symmetric, and they also have a vertical axis of symmetry. You flip them over.
Oh, that's
true. Here.
That's true.
So
that's
they
true.
both have 2 axes of symmetry, and the 2 axes of symmetry are respectively the same.
Right.
So they do not have axes. So they do not have different axes. They have the same axes of symmetry.
Right.
Okay, so what do? They have different vertices. Well, they do not have different vertices.
Yeah,
they have the same vertex.
We did that.
So we cross this out. Do they have different axes of symmetry? No. The axes of symmetry are the same. So A is a non-answer, B is a non-answer. The only answer is C.
Right.
Right? Yeah, well, the thing is, this silly SAT question is one of those questions that are unrealistic in life, in that they made up the question. They asked it in such a way that it only has one right answer.
Right. Now, most people... Now, wait. Let's go back a second. So, you did a full analysis of this question.
Well, I thought at first it was one of those questions where you had to choose there might be 2. This might have been the one that underneath is A is A and B, A and C is true.
Right.
One of those.
Yeah. But also, I mean, you went through some long analysis. Very few people are going to go through the analysis you just did to actually.
Well, what I did was visualize what the graphs look like, and then I did the analysis to explain to people what I had in my mind.
Yeah, but maybe you should have shown people the way you did it the first time so that people could do it in about 30 or 40 seconds as opposed to 8 minutes.
Well, before visualizing it, I did that. I actually told you what I did. I looked at the formulas.
Right.
And I looked for which parts were the same, which parts were different, and how were they different. I did that.
Yeah. Let me just go through how, I probably would have done it without all the analysis. Just blast right through it. I would have looked at these things. I'm in black. I would have looked at these things. The vertex of these parabolas are in what's called vertex form. And you could pick the vertex and the axis symmetry off these immediately. This one here is at -2,4. That's its vertex. And this one here is also at -2,4. So you immediately know that they have the same vertex. Okay.
Really?
So
no. When
-4, -4,
the
-4,
y.
-4. Sorry. I made a mistake. Although in the end, it really doesn't matter. For in terms of crossing this out, it doesn't matter. Fine. So yeah, I may rewrite it. The vertex for the first one, for this one, is -2, -4. The
No, yeah,
vertex for the
-4.
second
Yeah,
one
yeah.
is -2, -4. You can tell that immediately if you recognize that these parabolas are in called vertex form, which, by the way, is y is equal to a x minus h squared plus k. The vertex is h comma k. Okay? So you know that immediately. Now the axis symmetry is equal to x equals h, which means x equals 2. I'm not going to think about the trick about what Seth realized that they were actually two axis symmetry. I'm not going to worry about that now. So this is already immediately crossed out. They have the same axis symmetry. Then I go here, and then you do the analysis, Seth, which is completely correct. This goes up. So if this goes up, you draw a little picture because it's a +3. And this goes down because it's a -3, and then you realize, oh, the positive one has a minimum value, so this looks really good. This looks really good for the answer, and this one's the opposite, so you can sort of cross that off, and then you realize the answer is C. So this used both modalities of thinking algebraically, which was thinking algebraically was really doing this analysis, knowing here, this is thinking algebraically. Right? Immediately looking at something and knowing what the axis symmetries and the vertices are. This is an algebraic thinking. This is a graphical thinking, where if you have a positive and a negative, just because of up and down, positive, negative, you'll get messed up. So it's better to draw little pictures and realize that the +3 gives you a parabola goes up, and this one has a minimum value. So this uses the graphical thinking in algebra, the graphical modality, graphical language, graphical visualizations. So I would say the fastest way to do this problem would be this way: to recognize immediately vertex form, immediately just say, oh, those are the vertices. But then all that stuff Seth said about where x is equal to makes the quadratic term 0 is where the vertex is. That's all comes out of this, and that's more understanding of what's going on, and that's where the stuff comes from. But I don't know if it's necessary to do all that analysis doing the problem. So it's my take on it.
All right.
Yeah. Oh, by the way, let's see if we're right. See?
Well, we are right. We believe that we're right. We talked about it. We gave some rational discussion, and so we're pretty confident that's right.
We're pretty confident. But it's always nice to see the fireworks.
We'd like to see if we agree with the answer that they gave.
Right. Okay. Check answer.
They might be wrong. There might be a very serious flaw to everyone's thinking, and they're both wrong. We're wrong, and the answer they gave is wrong.
Let's see. Yes, we are right. So maybe what we should do
we agree with the SAT.
Well, maybe what we can do is, oops, what's that? Maybe what we could do is we can look and see how they did it.
Let's see. Let's more instructive. See their explanation.
Okay. Quadratic function. Oh, look at that! They did it the way I suggested. They immediately brought in the vertex form, and they recognized that H and K are the axis symmetries and the vertices without going through all the explanation as to why those are the vertices. They just expected you to know that, which is a good idea going into the test. It really is, because you don't have time to do the analysis to set it. No, wow, they bring in this fancy word called a concavity. That just means whether it goes up or down.
Go the concave down.
Yeah.
So concave down means it's the concavity.
That's fancy. Why don't they just say
cavity? The concavity is down.
Up parabola or down parabola?
Yeah.
That's
because one can get messed up with talking about it, because if you have a parabola goes like this, it kind of points upward, right? So this is said to be convex upward.
Yeah. Okay. Come on.
But so it's the sides of the parabola that goes down when it's concave down, and the vertex of the parabola goes up when it's concave up, or convex up, concave down are the same thing.
So that would confuse.
So when you say the parabola goes, all right, there's a parabola. Does it go to the upper right or to the lower left?
No, that's a weirdo parabola. That's a parabola.
It's a parabola on its side.
It's a parabola on its side. The
business of which way it goes, it's not very precise.
Yeah, I know, but you're bringing
it depends, walking along. Yeah. You go this way? Seth, or you're walking along. Or do you go that way?
We're talking about in the context of of the level of the types of questions there were. It's okay to understand things at the right level, to really have an intuitive understanding of things at the right level. Yes, when you get to a higher level and you realize problems can be sideways, maybe the words don't apply. But right now, you have normal looking parabolas that go vertical and horizontal, vertical parabolas. The up-facing parabola has the one that has the positive coefficient in front of the quadratic term. This thing. Oops, I didn't. What is going on? I have to annotate now. Annotate. Okay, annotate. When this term here, when this A is positive, the parabola faces up. Okay, it's like a dish or something. Actually, it is a dish because parabolas are useful in design.
Well, the x gets bigger and bigger.
Yeah.
We get x squared gets bigger and bigger.
Right.
Even when x becomes more and more negative, x squared still gets bigger and bigger.
Right. That's what the but something that is important about parabolas is they are symmetric. That's a very important thing. The other thing that's interesting, Seth, is I wonder whether they asked the question, whether they even considered anyone thinking about how these two parabolas have two axes of symmetry. Nowhere did they even mention that. That was a great observation, Seth said. These problems, where are the vertices, by the way? The vertices were -2, -4, right? So let's graph that. -2.
Well, the two parabolas together have two axes of symmetry.
Right.
But if one parabola is by itself, then it only has one axis of symmetry.
So it's really unclear in the question.
I think therefore from the elementary point of view, the question is about two separate parabolas. And so I was wrong in saying that they both have a horizontal axis of symmetry. That is wrong. No. The one that goes up is not symmetric around any horizontal axis. Right. But the two parabolas together form a configuration that is symmetric.
Right. Yeah, but I don't think it was the intention at all.
That was not the intent of that silly question.
That's right. That's what confused me there. Seth went a little overboard on that. By the way, they're very nice here. They graphed it. We don't know whether you will have a graphing calculator on the new digital SAT. I don't know. You have to check with your guidance counselors. You will be getting a calculator on the computer when you take the digital SAT starting in the winter of 2024 in the United States. And I don't know whether the calculator will include a graphing calculator, but if you bring the TID4, and I'm not even sure if you could bring your own calculator, you can always graph these things. But that would be very inefficient and slow.
Okay, well, I think I'd say prepare for the SAT. With these questions, take this as an approach to learn and remember. Because if you had to type in the symbols to graph that parabola, before seeing the answer, it would take you enormously. It'll take you. It'll be you'd spend a lot of time on this question.
Right, right. Notice they do not draw the horizontal line of symmetry. That Seth
No.
then said later that that he sort of like went a little bit too far. Okay, this is not right. This is not right. This was never part of the intention of the question. This
Yeah.
horizontal line of symmetry, comparing the two parabolas to each other. Seth went a little bit overboard, like on that. Okay, that's the line of symmetry.
Yeah.
Okay, so the way they really wanted you to do this was the normal, the very traditional way from in high school math to recognize that the parabola is in this type of form. See the word form, very, very important.
Mamma
Oh,
baby.
no. See the
Okay,
word,
you lost your screen
I
share.
lost my screen share. Sorry, I hit the wrong button.
Okay.
So I guess maybe that's it for
I
today.
think it's time to go home.
That's it for today. Okay, everyone, have a great day. Please like us, dislike us, give us comments on our YouTube videos, or send us emails at satmathquestionoftheday@gmail.com. And if you have any SAT math questions, please send them to us at satmathquestionoftheday@gmail.com. Have a great day, everyone. Bye.
Okay, have fun. Bye bye.